Okay, great. Welcome to our today's class. Today we are focusing on mathematics. We want to focus on an area called Surds. Surds is a mathematical concept that is being taught in book 3 and it is being examined in maths paper 2. It is really important for you to know about Surds. Surds are normally it can be 2 marks, it can be 3 marks. On the higher side it can be up to 4 marks. Let's dive into that maths concept. Yes, here we are. Let's focus on Surds. Yes, let's talk about Surds. So Surds is in maths paper 2, of course, and it can be of 2 marks, it can be of 3 marks or 4 marks. It depends on how it is examined in an exam. It has a tendency of always being in all the past maths paper 2 exams, so it is very important for you to know about it, because if you know about this concept, you already have your 2 marks, 3 marks or 4 marks in your Kcse exam. So Surds is very simple, and let's focus in it in detail. Great. So the first thing you need to know, how do you add Surds? How can you add Surds? Okay, addition of Surds. You want to see how do you add Surds? Addition of Surds. How do you add Surds? Okay, so before maybe I talk about addition of Surds, what are Surds? Okay, Surds are just mathematical figures which you leave them in roots, most of the time in square roots. So for example, we all know that a square root of 4 is 2. Square root of 9, we know that it is 3. Square root of 16, we also know that it is 4. Square root of 25, we know that it is 5. Now, what about the numbers that are not giving us the perfect squares? When I talk about the perfect squares, it means that these numbers, when you try to find their square root, you're going to get a whole number which does not have any remainder. So for the perfect squares, if you try to find their square root, you're going to find a whole number without any remainder. For example, 1 is a perfect square, 4 is another one, 9, 16, 25, 36, 49, 64, 81, 100, 121. Okay, those are perfect squares, because if you try to find their square root, you're going to get a whole number. So for the numbers that are not within the perfect squares, that is now, for example, 2, 3, 5, 6, 7, 8. We skip 9 because 9 is a perfect square. 10, 11, 12. As you move on with that list, so these are now this one. If you try to find their square root, you are going to find a number that has a decimal point. So it means that if you want to get back to the original number and you multiply the results, you are not going to be in a position to get the original number that you had. So the use of Surds assists in accuracy, and it eliminates the error that might come as a result of the decimal points, because you all know that for you to get an accurate answer, you need to write many decimal places. Okay, yes, for example, if you press on your calculator root 2, you are going to find 1 point something. There are many numbers are next to it. Okay, so because of that, because of the many numbers that are next to it, so sometimes we just decide to write 2 as root 2, so that when you leave it in that manner, its accuracy is still intact, because now a person will be able to use it the way it is as root 2. So that is now the element of Surds. So Surds will assist in eliminating the errors and improving the accuracy of answers. Yes, so sometimes you need to leave your answers in Surd form. So how do you add Surds? So in a very easier manner to understand things is this: Surds ni vitu ziko na root. Ukiona namba imeandikwa na iko ndani ya root, hiyo ni Surd. So how do you add Surds? Let's write it in terms of algebra. So let's say we have x root of maybe b plus maybe y root of b. Then how do you add surds? So in addition of surds, what is inside the root must be similar. What is inside the root here? For example, here, what is inside the root must be similar with this other one, okay? Yes, they must be similar. So you just add what is on the outside, that is x plus y, then you just retain your root b, okay? Just retain your root b. So for example, let's say we have 2 root 3 plus 4 root 3. So for you to add surds, what is inside the root must be the same. They must be of like terms. And when do we consider that they are of like terms? When what is inside the root is similar with what is also inside the root of the other number. So just add what is on the outside. So it will be 6. Then you just put your root 3. So that is how you add surds. The same way you add surds is the same way you subtract surds. Okay? The same way you also subtract surds of surds. So let's see how do we subtract surds. So the same way you add surds is the same way you subtract surds. Using the same algebra, x into root of b plus, no, this time we are subtracting. This time we are subtracting minus y into root of b. So you just subtract what is outside the root, then you just retain what is inside the root. But you ensure that they are of like terms. For example, let's say we have root 5 minus maybe let's say something like 7 root 5. So what will this one be? So when there is no number on the outside of that root, when there is no number on the outside of the root, it means that there is imaginary 1, there's a silent 1. So it means that you're going to subtract what is on the outside. So there is imaginary 1. So we have 1 minus 7. If you put on your calculator, you get negative 6. Then you just retain what was inside the root. Just retain what was inside the root. So that is how you add surds, and that is how you subtract surds. So whenever you want to add surds or subtract surds, they must be of the same like terms. So how can surds be of the same like terms? Kama kitu iko ndani ya root na kitu nyingine kiko ndani ya root nyingine zinafanana. Wakati vitu ziko ndani ya root zinafanana, hizo namba ziko nje hizo root unaziadd kama ni ya kuadd na una minus kama uliambiwa minus. Lakini unaweza fanya tu hivyo wakati tu what is outside the root. No, it is what is inside the root which comes first. So you can only add or subtract if and only if what is inside the root is the same with the other one. If what is inside the root is not the same as the other one, then that is the best it can be. You cannot add, neither can you subtract. So you can only subtract or add if and only if what is inside the root is the same with what is inside the root. What do I mean by that? For example, let's say we have something like this. 4 root 7 plus maybe 3 root 6 plus maybe let's say 6 root 2 minus let's say maybe 8 root 6. Let's say you have something like this. Let's say you have something like this. So if you have something like this and there is addition and subtraction, what you do here, you collect the like terms. And how do you collect the like terms? You check inside the root. So I'm able to see root 7, I'm able to see root 6, I'm able to see root 2, I'm able to see root 6 again. So there are only 2 like terms, root 6 and another root 6. So I'm going to have 4 root 7, just the way it is. There's no other root 7 plus there is a root 2. There is no another root 2. So I'm just going to put this one close to it. Then I collect my like terms. For my like terms are the 2 of this. That is 3 root 6 and also the other root 6. So we have 2 like terms here. That's why I'm putting them next to each other. That's why I'm putting them next to each other because we have only 2 like terms. Okay? So they are like terms because it is root 6 and another root 6. So I've collected the unlike terms. Then I'm also putting the like terms together. So that is 3 root 6 minus 8 root 6. So the first 2 I cannot add them because they are not in like terms. so I cannot add them because you consider what is inside the root, and what are inside the root are 7 and 2, and 7 and 2 are all the same. So now we can subtract this other one because it is 3 root 6 minus 8 root 6. It is root 6 and root 6. You can subtract. So you subtract what is on the outside. So that is 3 minus 8. You get negative what? That is negative 5. 3 minus 8, you just put on a calculator, you'll be able to get negative 5. Then you just retain root 6. So this is the best that answer can be. That is the best form of this answer. So that is the best of that answer because root 7 is not the same as root 2, and also it's not the same as root 6. So that is what I mean when I talk about addition and subtraction of surds. Let's talk about how do you multiply surds. Let's talk about multiplication of surds. Multiplication of surds. So let's talk about multiplication of surds. So when you're talking about multiplication of surds, how do you multiply surds? So unlike addition and subtraction, in multiplication of surds, you don't care whether what is inside the root is the same as what is also inside the root of the other. No. In multiplication of surds, you don't consider that. You just multiply. You can multiply anything. So let's say maybe we have a root of m times maybe b root of n. So in multiplication, they can be different. So you multiply. So what is very simple here is this. What is outside the root, you multiply by what is outside the root. Then what is inside the root, you multiply by inside what is inside the root. That's how simple it is. For example, if you have 4 root 3 times maybe 6 root 2. So how do you go about this? So what is inside the root, we multiply by what is inside the root. What is outside the root, we multiply by what is outside the root. So let's start with what is on the outside the root. That is 4 times 6, that is 24. Then the square root of 3 times 2, you get 6. So that's your final answer, 24 root 6. So that's how simple it is. What is inside the root, you multiply by what is inside the root. What is outside the root, you multiply by what is outside the root. So that's how simple you multiply surds. And there is always a certain shortcut. When what are inside the root are the same, let's say root a times another root a, the answer is always just a. When what is inside the root, we multiply by something else that is inside the root, the answer will always be the number that was inside the root. What do I mean by that? Let me show you an example. Let's say, for example, we have let's say root 5 times root 5. Okay, in multiplication of surds, you have said that you multiply what is inside the root with also what is inside the root. So that is 5 multiplied by 5. Okay, you get root 25. And the square root of 25 is 5. The square root of 25, we all know that it is 5 because 25 is a perfect square. 25 is basically a perfect square. So that is how it will keep on behaving till the end. For example, if maybe we have root 3 times another root 3. So if you multiply 3 times 3, you are going to get 9. And the square root of 9 is known. It is 3. So that is what I meant by that other one. So an application, I can also give you another application in this sense. Let's say maybe we have 3 root 7 times 2 root 7. Now, in a scenario like this, we multiply what is outside. What is in a scenario like that, we multiply what is outside the root, which in this case is 3 times 2. Then we go ahead to multiply what is inside the root. Remember, you have said that if you multiply 2 similar answers, if you multiply 2 similar roots, you end up having the number that was inside the root. So that will be 7 times 7. And 7 times 7 is 49. And what is the square root of 49? It is the very same 7. So it will be 7. So then you multiply everything now. 3 times 2, that is 6. 6 times 7 is 42. So your answer this time will be 42. It will not have any square root. It will not have any square root. So I believe you're in a position to see how we work it out. So let's check on an example. Let's check on a sketch example. Sometimes in Surds, you can be given something like this. Examples. Sometimes in Surds, you can be given something like 1 over root 3. And you'll be told to simplify. Okay, when you have a single denominator, like for example this one, when you have a single denominator, like in this case, what you simply do, so that is my question. The question will be just simplify that 1 over root 3, simplify. So what you'll do, you'll multiply by the denominator, the single denominator. In this case, we only have a single denominator, so you'll multiply by root 3. The lower one you also multiply by root 3. That is how you do it. So Surds, that is how you do them. Okay, you multiply the upper one by root 3, also the lower one you multiply by root 3. You multiply by what is on the lower side. So let's start with the numerator. So the numerator will be, the numerator is what is on the upper side. It is 1 times root 3. Remember, in mathematics, 1 times anything, it always remains the way it is. Okay, yes. So 1 times root 3. That is just like 1 root 3 or just root 3. So on the numerator we have, so on the numerator we just have root 3, because 1 times root 3 is just the way it is. Then on the denominator, what do we have? Root 3 times root 3. And what did we say about this thing? We say that when you have what is inside the root is similar with another thing that is inside the root, the answer ends up to be what? To be just 3, because it will be root 9. And root 9, the square root of 9 is just 3. So with this, now you combine your answers. So it is root 3, because that was the numerator, then the denominator is 3. So, and that's your answer. And with that, you would have simplified your Surds. With that, you would have simplified your Surds. So when the denominator is only 1, you multiply by that denominator, okay? You multiply by that denominator. Let's check on another example. Let's check on another example, a Kcse example actually. Let's check on this example. This is a Kcse example. This is Kcse 2022 Maths Paper 2. This is Kcse 2022 Maths Paper 2. Let me show you up here. I think you're able to see it. Yes, you can see it by yourself. This is a Kcse exam. Kenya National Examination Council, Kenya Certificate of Secondary Education, Mathematics Paper 2. Okay, Alt A Paper 2. Okay, yes. So that is what you're doing. So let's do it. So simplify. 3 plus root 5 over 7 minus 3 root 5, leaving the answer in the form a plus b root of c, where a, b, c are integers. 2 marks, only 2 marks. Okay, yes. So in an exam, you always make some space, you create some space. You normally do it in that sense, so that you can create the 2 spaces, so that you can do your maths. So we have 3. So the question is 3 plus root 5, then 7 minus 3 root 5. So in a scenario like this, you always multiply by the denominator. But in this scenario, our denominator is not just 1. The example I've just given you, the denominator was only a single. It was only 1 by itself. So in this scenario, we multiply by the denominator, but there's something that we do. So our denominator is 7, and there's a minus between it, because our denominator is the one that is on the lower side. That is 7 minus 3 root 5. So what do you do from that point? So you only change the sign that is in between the denominator. So if our denominator had a plus, I'll now write this one with a minus. And in this case, our denominator has a minus, so I'm going to write this other one with a plus. So it is 7 plus 3 root 5 over the same thing, 7 plus 3 root 5. So this is what you do. So you multiply. Normally, what do? You multiply by the conjugate. Mathematics call it conjugate. You multiply by the conjugate. The process of doing this is called rationalizing. You rationalize. The process is called rationalize. So we are rationalizing. So you multiply by the conjugate. What is a conjugate? A conjugate is that denominator whose sign, the sign at the middle, has been changed. If it was a plus, you now use a minus, and if it was a minus, you now use a plus. So you multiply by the conjugate. That is what the conjugate is. Now the conjugate will always be the one that is on the lower side. We call it denominator, and the process of doing all this is called rationalization. So let's move with it. So after doing that, what you now do from that point is you just obey the usual order of operations of Surds. How do you multiply them? How do you add them? How do you subtract them? That's how simple it is. So let's proceed with our maths. So let's start with the numerator. NUM, short abbreviation for numerator. Numerator is the one on the upper side. So in the numerator we have 3 plus root 5 into the other one is 7 plus 3 root 5. So we are going to multiply them. So what you need to do, the 3 we multiply by everything. These 3 we multiply by everything that is on our right hand side. Hii 3 tunachukua tuna times na kila kitu iko hii side nyingine. Hiyo 3 tuna times na hiyo 7 plus 3 root 5. Tena hii plus root 5, so naona nimechukua hii 3 ya kwanza na times na kila kitu iko kwa hii bracket ya pili. So nimechukua 3, nataka ni times na kila kitu iko kwa hii bracket ya pili. Tunaelewana? Then tena hii plus root 5, the plus root 5 I also multiply by kila kitu iko hii on our right bado tena na multiply na 7 plus 3 root 5. That is how you normally expand. It's called expansion. That is how you expand, okay? This is how you expand. So to expand is very simple. You just take the first part, you multiply by everything that is on the second part. Then you also take the second number, you multiply by everything that is on the second bracket. That is how you do it. Then from there you just obey the usual laws of multiplying and adding and subtracting Surds. So let's go away with this. So 3 times 7, that is 21. Then remember 3 is a natural number. It is a number, and when you're multiplying Surds, because 3 times 7, that is a number and a number. Okay, that's why it's 21. But 3 times 3 root 5, so 3 is a number, you multiply by what is also a number, because 3 root 5, 3 which is on the outside is a number, so 3 times 3, so that is 9. Then you are remaining with root 5. So the root 5 has not changed because the root 5 is inside the root, and we say that you can only multiply and what is outside the root and what is outside the root, and what is inside the root with what is inside the root. And these 3 is not inside the root, it is a natural number, so that is why I've multiplied it number by number. Then let's go to the second part of the bracket. So this one is going to be root 5 times 7. 7 is a number, root 5 is inside the root, so it is a Surd. So that is going to be just 7 root 5, because 1 is a number, the other one is a root. Then lastly, plus root 5, you know we have root 5, we want to multiply by 3 root 5. So root 5 you multiply by root 5. If you multiply root 5 by root 5, you get root 25, which is 5. So then the 5 you multiply by the 3 that was next to root 5. So that is 5 times 3, so you get 15 there. Okay, so there you get that one. Then you collect the like terms. So if you collect the like terms here, then what do we do? Very easy. So let's collect the like terms. So the like terms here will be 21 plus 15. So that is what we'll add. That will be 46. So because they are like terms, it is a number and a number. 21 plus 15, it is a number and a number. Okay? Yes, that's a number and another number. So we just add it, okay? You just add it. Number and a number, you just add it. So you just add the numbers. You take a number and another number, then you add them. That's how simple it is. Nothing difficult. So 21 plus 15, no, that's 36, not 46. Okay? Sorry for that. That's 36, not 46. So 21 plus 15, so you take a number and a number. That is how you add them. 21 plus 15. A number plus a number, you get 36. Then you go to the other one. 9 root 5 plus 7 root 5. Okay? So they are like terms. Why are they like terms? Because we have root 5 and root 5. In addition of Surds, to consider what is inside the root. So it is root 5 and root 5. So they are like terms. So you add what is in front, that is 9 plus 7. So you get 16. So that will be 16 on the outside. 16. Then we now just place root 5 next to it. You just add what is in front. So 9 plus 7, you get 16. So 16 root 5. So we'll be done with the numerator. Let's go to what? Let's go to the denominator. So denominator, there's always a shortcut of doing it. Mathematically, they say that a plus b, when you multiply by a minus b, is the same as when you square a minus when you square b. This one is a mathematical identity. This one is a mathematical identity. So mathematically, they say that when these two numbers, the difference is only plus and minus, then unakubaliwa kusquare to a, alafu square to b, alafu katikati weke minus. That is what I'm saying. Okay? So our a ni ya kwanza 7 na b yetu ni 3 root 5. So you just square our a. So our a ni ya mbele. So our a is 7. So you just square your a, which is the first one. The first one is always our a. So our a is 7, you square it. Then you put a minus, then you square your b. B is 3 root 5. You square your b, then you just minus, then you get an answer. So 7 when you square, that is 49, minus, then let's square 3 root 5. So we're going to square them. To square is to multiply something by itself. Like for example, 7 square, that is 7 times 7, it is 49. So let's square 3 root 5. We want to multiply 3 root 5 by another 3 root 5. So 3 times 3, we are going to get 9. Then root 5 times root 5. Okay, so root 5 times root 5, we know that will be root 25, which later will be square root of 25 is known, it will be 5. So the 9 that we had from multiplying 3 by 3, so that's 9 times 5, so we get 45. So from that side, so 49 minus 45, our denominator, the answer is 4. So the answer is 4. Great. The answer is 4. Now let's put our answers together. So the upper answer was, so let's put our answers together. So the upper answer was 36. It was 36 plus 16 root 5. Then we are dividing by denominator, which is 4. So in this type of maths, they share the 4. They share, this is like an LCM, so they share the 4. So we are going to give the 36 it's 4, and we are also going to give 16 root 5 also it's 4. So if you simplify, 36 divided by 4, of course we all know that is 9. So let me write our answer in a different ink, maybe this one. So 36 divided by 4, that is 9, plus the number and the number. 16 divided by 4, you get 4. So it is 4 root 5. So that will be our final answer. And indeed, it meets what the question had said, because the question had said, let's have our answer in the form a plus b root c. So walimaanisha yani, tukue na kitu iko peke yake, na 9 iko peke yake, tukue na kitu imeshikana na square root. So our b, which is 4, and then evil. So tumepanga in the form that they wanted. So that is how you get your full marks. So that is how you get your full marks. So Surds is very easy. I know you people are going to understand it. Thank you so much. That's the end of our class in Surds. Thank you so much. See you some other time. Bye for today.